Good morning, students. Now, I just tell you, we have come to the end of this rotational motion chapter, and in today's class, it will be concluded. Right? So, what is our discussion? What is our next discussion, which we are going to do? That is, point mass on a string, wound on a cylinder. Try to follow. This is a solid cylinder. This is a solid cylinder. This is dotted line. This is the axle. That is the axle of this solid cylinder. Right. And on this solid cylinder, a string is wound on it. Completely inextensible string is wound on this cylinder. And this is this end which is going. In this, a point mass M is attached. A point mass M is attached to this. Here the cylinder has the radius capital R. Okay. And what we are doing, just try to understand, it is this mass, point mass, is just held in its position. When it is released, when this point mass is released then what will happen? The string will unwind and the point mass will move downward. If we take it according to the cross-section side, if you see the cross-sectional view of the cylinder, it will be like this. The point mass will fall with the acceleration A. Suppose with the acceleration A it will be going down. It will move down. Tension will be upward direction. And here it is moving in the downward direction. Look as it is here. Right. Then if I ask you what should be the equation of motion, then you can very easily say that its mass, a weight mg should act, its weight mg must act in the downward direction. So mg minus t is equal to mg. Mg minus t is the tension, is equal to mg. This is according to Newton's second law. Net force which is acting in the downward direction is this. Right. Now, if you remember my previous class, I told you always that whenever there is a rotational motion, there will be a torque, and torque is always due to the tangential force, not due to the radial force. So, torque is due to the tangential force. Tangential force is which? Which one is the tangential force? Here, tension is the tangential force. So, tension is the force due to which the torque will be there. So, now, the torque. Obviously, torque tau is equal to I into alpha is equal to T into R, because in between T and R there is an angle of 90 degree. T is the tension in the string. Here T is the tension in the string. Okay. Tension in the string. I is the moment of inertia of the cylinder. Alpha is the angular acceleration. It will be like this. Or we can say I into A by R, that is equal to T into R. That is also clear, because angular acceleration is equal to the linear acceleration by the radius. Already done. We have done it. So T is equal to how much? I A by R square. This is the value of the tension. So we have, from above equation, we have mg minus Ia by R square is equal to m. Or we can say here A is common, m plus I by R square is equal to mg. We can take this also, or the next step will be A into m1 plus I by R square is equal to mg, M and M cancels, which gives us A is equal to G divided by I plus 1 plus I by R square. See, A is equal to G divided by 1 plus I by R square. This is the acceleration. Very simple. This is the acceleration here of the point mass moving down this. I hope it is very much clear to you. This is the discussion. Okay. Now, here, this was about this discussion. Now, I want to discuss a very important situation. Look, it is the NCERT, okay, example 7.16. All of you are having NCERT. This is the 7.16. This example is very important, so I want to discuss. This discussion is over. I want to discuss this example. 3 bodies: a ring, a solid cylinder, and a solid sphere, roll down the same inclined plane without slipping. They start from rest. Radii of all the bodies are identical. Which of the bodies reach the ground first with maximum velocity? Look, the situation is like this. I first tell you the situation. From the top here, it starts its center of mass, a straight diagram, and it will be ultimately coming down to here. This height is h. Here it is. This is the situation. What are the bodies? 3 bodies. In the problem, they have mentioned about 3 bodies: a ring, a solid cylinder, and a solid sphere. A ring, a solid cylinder, and a solid sphere. One by one, they are allowed to fall. Which one will reach the bottom with the maximum velocity? That has been asked. Okay, fine, very good. What we shall do here, when it is moving in this way, then what will be our main thing in this? You can see what will happen. It will be, when it is falling down, potential energy lost by the body is equal to the kinetic energy gained by the body. Potential energy will be lost according to the transformation of energy. Potential energy will be lost, kinetic energy will be gained. Potential energy U, kinetic energy kT plus kr. One is the translational, another is the rotational. I have mentioned it before. If it is here, if it is rolling, pure rolling case, then rotational motion and translational motion both will be associated. Rotational motion and translation motion of the center of mass. So what we can write? mgh is equal to half mv square, that is the translational, and half I omega square is the rotational. Alright, half I omega square will be the rotational. This will be the value. Now what we shall do in this? We shall write in this half. Here it is mv square plus half. Here I, if I say in this I omega square, so you can write I omega square, you can write m into k square omega square to write omega square, no problem. That means half mk square, this way. Okay, fine. Half v square plus half m capital K square, and it is v square by r square. Okay, this is mgh. That means mv square. That means how much we are getting? mgh is equal to half mv square 1 plus k square by r square. M and m cancels. Okay, then v square is equal to 2gh by 1 plus k square by r square. This will be actually our guiding formula. This will be our guiding formula. Now you take the cases, the different cases. You take the case one by one. If you take the case for now, for ring, I just give you the hint, ring. In case of the ring, what is here? What is the value of I? I is equal to mr square only, or I mr square is equal to mk square. How much will be the k square? K square will be r square. Then what is vr square for ring? 2gh divided by 1 plus r square by r square. Means what? Only gh. Vr square, so Vr will be root gh. That is what. Similarly, you do it for the others. Solid cylinder. For solid cylinder, if you take the case of solid cylinder, what is this? I is equal to m k square is equal to m r square by 2. How much it will be? mr square by 2. Then v solid cylinder c square is equal to 2gh by 1 plus k square r square by 2 into r square. This will be cancelled. How much we shall get? We shall get here, it will be 3 by 2, 4gh by 3, means 4gh by 3. That means you can say it is 1.33 gh. So Vc is equal to root 1.33 gh. And lastly, solid sphere. What will be that? I is equal to mk square is equal to 2 by 5 mr square. So what is k square? It is 2 by 5 r square. Put it in this. Put it here in this, and you can find out. I think Vs you can find out. Okay, you will see that for sphere will be the maximum, followed by the cylinder and then the ring. That means whose will be the maximum? Whose will be the maximum? For the solid sphere will be the maximum. Very simple it is. In this way we can solve it. Okay, ऐसे हम लोग निकाल सकते हैं. इसका मतलब हुआ solid sphere will reach the bottom first, followed by the cylinder and ultimately by the ring. Okay.